Ever heard the phrase, a butterfly flaps its wings in Brazil and a tornado forms in Texas? It might sound like science fiction, but it's rooted in chaos theory and the butterfly effect. Today, we're diving into this fascinating idea where small causes can lead to massive effects. The butterfly effect was popularized by meteorologist Edward Lorenz in the 1960s. While working on weather simulations, he discovered that a tiny change in the input of initial conditions, like rounding a number from 0.506127 to 0.506, led to vastly different outcomes. This small change set off a chain reaction, leading to unpredictable weather patterns, hence the metaphor of a butterfly causing a tornado. Now, what exactly is chaos theory? It's the study of systems that are extremely sensitive to initial conditions. Imagine a pendulum. Its motion is predictable, and we know exactly where it will swing. But when we add another pendulum to the system, things get chaotic. A tiny variation in how you release it causes totally different swings. This is a chaotic system, where small differences at the start lead to wildly different outcomes. Lorenz discovered this phenomenon while trying to predict weather. Even the tiniest difference in initial data, whether it's wind speed, temperature, or pressure, can drastically change the outcome. This is why predicting weather more than a few days in advance becomes nearly impossible. Chaos theory explains why these tiny changes amplify over time, making long-term prediction chaotic. Think of it like a fractal. No matter how much you zoom in, the pattern repeats, revealing ever smaller details. Similarly, in chaotic systems, small changes get magnified over time, leading to unpredictability, but the system still follows underlying rules. Let's look at other examples. Take traffic flow. If a driver taps their brakes, cars behind them might slow down, and a minor event can cascade into a traffic jam. The system obeys basic rules, but tiny changes lead to chaotic outcomes. Or, in ecology, a small increase in the rabbit population can affect the wolves. A tiny initial change can cause unpredictable fluctuations in predator-prey populations. Even simple ecosystems can behave chaotically over time. So what does chaos theory really teach us? Even in deterministic systems, where the rules are clear, outcomes can be unpredictable if the initial conditions aren't perfectly known. This sensitivity to starting points is the essence of the butterfly effect. Take a look at the Lorenz attractor, a mathematical representation of chaos in weather systems. Its pattern never repeats, yet it stays within this beautiful butterfly-like shape. Even though the system is chaotic, it has structure. Chaos theory isn't just about weather. It applies to many systems, from financial markets and heart rhythms to planetary orbits. These systems follow predictable rules, but their outcomes are incredibly sensitive to initial conditions, making long-term predictions nearly impossible. The butterfly effect reminds us that the world is deeply interconnected. Small actions can ripple through complex systems, leading to dramatic consequences. A flap of wings, a slight change in data, or a small event can lead to massive outcomes. So, next time you hear the term butterfly effect, think about how even the smallest changes can cause a chain reaction in chaotic systems, leading to outcomes we never imagined. It's a reminder that the universe is full of surprises, driven by the smallest details.